Imagine trying to fight a war where your biggest enemy isn't actually the guy shooting at you, it's the air you are breathing.
Yeah, that's exactly the scenario.
Right, so it's October 1962. You are an Indian soldier standing next to a freezing river. You are, 15,000 feet above sea level. You are in summer cotton uniforms because the supply trucks literally just can't reach you.
Which is a terrifying position to be in.
Absolutely. The temperature drops to negative 50 degrees Celsius at night. If you want to retreat, your only path is to walk across a single slippery felled log over a torrential current. And if you need reinforcements, well, they are 205 kilometers away, and they have to walk to you on foot, climbing vertical cliffs.
It is the absolute definition of a hostile theater of war.
Mm.
I mean, usually we think of the terrain as just the board you play the game on. But in the Himalayas, the terrain isn't the board. The terrain is the opponent.
And that is exactly why we are tossing out the traditional history books today. We aren't going to talk about sweeping political speeches or just tallying up troop numbers. We are pulling out the operational map. Welcome to the deep dive. Our mission today, for you, the listener, is to answer one incredibly vital question. How did the sheer, unchangeable facts of the Earth crust directly dictate the outcome of the 1962 Sino-Indian War?
As a military geographer and an operational warfare analyst, I always start with a foundational rule. Terrain is not a background. It is an active participant in war. The Earth dictates terms to armies.
Right.
It dictates movement, logistics, deployment, your ability to achieve surprise, your firepower, and your long-term sustainability.
So we're essentially looking at geography as a weapon.
Precisely. And to frame our entire conversation today, I want to give you an equation, a formula to keep in the back of your mind as we analyze every single mountain pass and river valley.
Okay, let's unpack this. What's the formula?
Here it is. Terrain plus infrastructure plus logistics equals combat capability.
Let me make sure I have that locked in. Terrain plus infrastructure plus logistics equals combat capability.
Exactly.
So the logic is you can have the most elite, well-trained, heavily armed troops on the planet, but if the terrain is so vertical that you can't build infrastructure like roads, then your logistics fail because you can't feed those troops.
Right, and your combat capability effectively drops to zero. That is exactly the mechanism at play. If you do not understand the rock, the ice, the gradients, and the altitude, you simply cannot understand the 1962 war.
Which is wild to think about.
It really is. To start proving this, we need to pull the camera way back.
Yeah.
Before we zoom in on individual soldiers shivering by a river, we have to look at the massive geological structures that built this battlefield. We have to start at the roof of the world.
You mean the Tibetan Plateau?
Yes, exactly.
Because when you look at the topographical data, the sheer scale of the Tibetan Plateau breaks your brain a little bit. We are talking about a landmass that measures roughly 1,000 kilometers wide by 2,500 kilometers long.
It's massive.
Yeah, that is an area larger than much of Western Europe, sitting right at the roof of the Asian continent.
And the horizontal scale is only half the story. It's the verticality. It rises to an average height of 4,510 meters. That is nearly 14,800 feet above sea level.
That's just wow.
Right. This comprises modern-day China's Qinghai and Tibet autonomous regions. Geographically, it is an upland that is desolate, incredibly dry, interspersed by mountain chains, and mostly consisting of a frozen, stony desert.
Okay, let me push back right here because this is where my intuition gets tangled.
Sure.
You are describing a frozen, stony desert at almost 15,000 feet. The air is so thin you can barely breathe. From a civilian perspective, this sounds completely hostile to human life.
It definitely is hostile to civilian settlement.
Right, so how does an army even survive there, let alone use it as a strategic advantage? I mean, wouldn't military trucks just freeze or get bogged down in endless snowdrifts?
That is the exact paradox of the Tibetan Plateau. What is hostile to agriculture and civilian settlement can be incredibly advantageous to a certain type of military engineering. Let's break down the surface characteristics. The plateau sits in what we call a precipitation shadow. The massive Himalayan mountain range to the south basically blocks the monsoon clouds coming up from the Indian Ocean. So the plateau actually gets very little rain or snow compared to the southern slopes.
Ah, so it's a cold desert, not a winter wonderland.
Exactly. And the ground itself is barren and stony. Now, combine poor precipitation with a stony surface. What does that mean for infrastructure?
Oh, I see. It means you don't have mud.
Yes. It means you can build roads that require significantly less maintenance. You don't have mountainsides washing away in torrential rainstorms every week.
So because it's dry, compacted rock, it's essentially nature's concrete.
Precisely. The operational effect of this geography is profound. It facilitates the construction of roads capable of handling sustained, heavy traffic, and not just in the summer, but throughout the year. The geography enabled a freedom of movement for troops and material that was, frankly, utterly impossible on the Indian side of the border.
I see. Think of it as a massive pre-paved staging ground sitting right above the battle space. You have this gigantic, flat-ish parking lot in the sky where you can marshal thousands of troops, park hundreds of trucks, and stockpile ammunition without the environment actively trying to destroy your supply lines every single day.
That is the perfect analogy. And that staging ground is bordered by some of the most formidable mountain ranges on Earth. To the south, separating this staging ground from India, is the Himalayan barrier.
Let's talk about that wall, because if the Tibetan Plateau is the staging ground, the Himalayas are the fortress walls separating the two nations. This mountain range spans more than 2,400 kilometers along the frontiers.
2,400 kilometers of jagged rock and ice. The average height of this boundary, especially in the western Karakoram ranges, is around 6,000 meters. That is nearly 20,000 feet. The highest peaks punch past 8,600 meters.
Unbelievable.
Now, within this massive 2,400-kilometer wall, there are roughly 114 passes. Some are perennial, meaning they can be traversed year-round, while others are blocked by snow for 6 months of the year.
Right, 114 gaps in a 2,400-kilometer wall. But let's apply our formula here. How does a wall like that function in a war? Because obviously it's a barrier for both sides, but it doesn't affect them equally, does it?
Not at all. It has a dual nature based entirely on which direction you are facing. Let's look at it from the perspective of an attacker coming from the north, from the Tibetan Plateau.
Okay.
For them, the Himalayas act as a formidable natural obstacle. It restricts their movement. They cannot just march an army in a broad, sweeping line. They are funneled. They are forced to squeeze their forces through those specific 114 choke points.
Right. You can't roll a supply truck over a 20,000-foot pick. You have to thread the needle through the passes.
Precisely. But now look at it from the perspective of the defender in the south, the Indian forces. For them, the barrier is a different kind of nightmare. It is a logistical black hole.
Wait, how so?
Well, to defend those passes, you have to get troops up to them. That means starting from the plains of India, near sea level, and climbing up incredibly steep gradients, hacking through dense, malaria-infested jungles at the lower altitudes, and fighting relentless monsoon weather just to reach the battlefield.
If it's such a massive barrier, how does an army even begin to plan an approach? So the attacker has to squeeze through a door, but the defender has to climb a greased ladder just to reach the doorknob.
That's a great way to put it.
But wait, if the attacker's coming from the north, and they are sitting on this barren, stony staging ground, how do they get their supplies there in the first place? You said Tibet is a wasteland. It can't grow enough food or produce the fuel needed for a massive, modern, mechanized army.
Yeah.
If the staging ground is empty, how does an army organize an offensive?
If we connect this to the bigger picture, that is the crucial question, and it drives us straight into the geopolitical imperative that set the stage for this entire conflict. Logistical depth.
Okay, logistical depth.
Yes. You cannot push an army through a bottleneck unless you have an ocean of supplies pushing from behind. To utilize Tibet, China had to be able to get vast resources into Tibet. And to understand how they did that, we have to look far to the north and west. We have to look at Xinjiang.
Xinjiang. When you look at the map of China, it's that massive territory taking up the entire northwest corner. It accounts for more than 1/6 of China's total land area.
Look at its connectivity. It shares borders with Russia, Mongolia, Kyrgyzstan, Tajikistan, Afghanistan, Pakistan-occupied Kashmir, and India. A quarter of China's total border length is just Xinjiang. It is the ultimate geopolitical hub.
And it's incredibly wealthy in terms of raw materials, right? The sources highlight that it sits on massive deposits of fossil fuels like oil, gas, coal. It is an absolute powerhouse of resources.
Because of that strategic location and immense resource wealth, the Chinese state planned to develop Xinjiang as a primary population, industrial, and communication hub. It was the anchor for their control over the western half of their territory.
Makes sense.
But, and here's where the geography dictates the politics, having a powerhouse is useless if you can't plug it into the rest of your grid.
Right. Tibet is sitting there isolated, massive, bordering a major rival in India and desperate for logistical support. Xinjiang has the oil, the industry, and the supply lines. You have to connect them.
Connecting Xinjiang to Tibet was an absolute operational necessity. But doing so presented a terrifying geographic challenge. The Kunlun mountain range stands between them. To build a road from the heart of China to western Tibet meant navigating some of the most rugged, impassable terrain on Earth, unless you went through one specific high-altitude anomaly.
And here is where we get to the spark that lit the powder keg, the Aksai Chin. Let's do a deep case study on the Aksai Chin because physically, based on the topographical records, this place sounds like it belongs on Mars, not Earth.
It is one of the most geographically extreme places on the planet.
It sits at an average altitude of 5,300 meters. That's over 17,000 feet. It is completely enclosed by towering mountain ranges, with the Kunlun Mountains to the north and the Karakoram to the west. The sources describe it as an arid lacustrine desert with a severe water deficit.
Which means it's a desert formed from the dried-up bed of an ancient lake. It is bone-dry, freezing cold, and practically devoid of life.
So the obvious question you, the listener, should be asking is why did two massive nations go to war over a frozen, waterless, lifeless lake bed at 17,000 feet? Why did this specific patch of dirt end the era of goodwill between India and China?
It goes right back to the formula: terrain plus infrastructure. Let's create a new equation specifically for this region. Aksai Chin equals connectivity plus military movement plus strategic depth.
Okay, I like that. Connectivity plus military movement plus strategic depth.
Western Tibet and Lhasa were geographically agonizing to reach from eastern mainland China. But from Xinjiang, access was much easier, provided you cut straight across the Aksai Chin.
Because it's flat, it's a desert. Even though it's incredibly high up, the ground is just compacted salt and stone. You don't have to blast tunnels through 100 jagged granite peaks. You don't have to build suspension bridges over 1,000 torrential rivers. You literally just flatten the dirt and lay down a road.
Exactly. The barren, desert-like nature of the Aksai Chin offered a massive engineering advantage. It permitted the rapid construction of surface communication. It even allowed mechanized forces, trucks, jeeps, light armor, to drive off-road in the basin and valleys.
So it was a perfect route.
It was the only viable flat bridge connecting the two most critical western regions of the Chinese state.
And looking at the historical timeline impartially, the sources show China didn't wait. They began building a motorable highway across the Aksai Chin in 1951. India formally protested this road building with an informal note in October 1958. China countered by claiming it was actually the Indians who had intruded into Chinese territory.
Right. And just like that, geopolitics was hijacked by geography.
This barren, high-altitude anomaly ended the era of goodwill purely because of its geographical connectivity. So Aksai Chin hands one side a massive high-speed highway right on the border that completely warps our combat capability equation. This perfectly sets up what I want to talk about next, which is the great infrastructure asymmetry. Let's break down exactly what this built.
The asymmetry is perhaps the single most defining operational feature of the 1962 war. Let's start with the Chinese advantage. Because they had the flat, dry Tibetan Plateau and the Aksai Chin, they didn't just build one road. They built a primary motorable highway from Gartok via Rudok straight through the Aksai Chin to Xinjiang.
That's the main artery, the highway. But a highway isn't enough to fight a war along a 2,400-kilometer front, right?
Correct. What made their infrastructure truly lethal was the network they built off that main artery. They constructed subsidiary lateral roads branching out towards the west at numerous critical places. They built roads connecting their forward military posts at Lanak La and the massive Pangong Lake.
Let's define lateral for a second, because this is a huge concept. A lateral road means a road that runs parallel to the front line, side to side, left to right.
Yes. And furthermore, because the terrain of the Tarim Basin and the Tibetan Plateau was so flat and arid, transport could move in most areas even where there were no roads at all.
That is an unbelievable tactical advantage. If you have lateral roads and you can drive off-road across the desert, you have absolute operational speed. You can shift your forces laterally to concentrate your firepower wherever you want, and you have a massive highway behind you, ensuring your sustainment.
Now, compare that freedom of movement to the Indian infrastructure challenge.
This is where the geography just becomes cruel. The Indian side of the frontier, particularly the greater Himalayas, is characterized by extreme ruggedness. Look at the starting altitudes just for the administrative towns. Leh sits at roughly 10,000 feet. Chushul is at 12,600 feet. The mountain passes are between 14,000 and 17,000 feet.
Which means fighting gravity every single inch of the way. And what kind of roads were they actually building? The topographical records mention Class 9 and Class 5 roads.
Wait, what does that actually mean in reality? Class 5 and Class 9?
In military engineering terms, a Class 9 road can handle medium-heavy traffic, like 3-ton supply trucks. A Class 5 road is significantly lighter It can barely handle a 1-ton vehicle like a Jeep, and even then, only in good conditions. And in the Himalayas, good conditions do not exist.
Especially in the eastern sector. In the east, you aren't dealing with a dry, cold desert. You are dealing with thick, impenetrable jungles and incessant monsoon rains.
The eastern weather causes constant landslides. You could spend 6 months carving a Class 5 dirt track into a mountainside, and one heavy night of monsoon rain will wash the entire slope away.
That is soul-crushing for an engineer.
It really is. But the absolute worst geographical feature for the Indian side, the trap that doomed their lateral movement, is the north-south river valley configuration.
Okay, break this down for us.
This is a masterclass in the geometry of warfare. In the eastern Himalayas, the major rivers flow down from the Tibetan Plateau into the Indian plains. Because water flows downhill, these rivers carve deep, massive valleys that run essentially north to south.
Right. And if the valleys run north to south, that means the massive, jagged mountain ridges separating those valleys also run north to south.
Exactly. Therefore, if you are a military engineer trying to build a road to supply your troops at the northern border, your road is strictly limited to following the floor of that north-south valley. You build your road alongside the river, heading north.
So you have a road going straight up to the front line. But what happens if the troops 10 miles to your east need reinforcements?
You cannot help them.
Mm-hmm.
To move laterally, to move from your valley to the valley just 10 miles to the east, you would have to build a road that turns 90 degrees, goes straight up a sheer 15,000-foot mountain ridge, and goes straight down the other side into the next valley. It is an engineering impossibility.
Wow. So lateral communication was practically, I think the source says, well nigh impossible. You are entirely siloed. The Chinese are moving their troops left and right like pieces on a wide-open chessboard. But the Indian forces are stuck at the bottom of these north-south vertical shafts.
That geometric trap severely handicapped Indian deployment and reinforcement. Ahead of major towns, there were no roads at all. There were only mule tracks and footpaths. Roads could only be completed after the war ended.
The logistical equation severely handicapped them. So now that we understand this broad logistical equation, let's apply our analytical framework to the specific battleground sectors sweeping from west to east.
Let's begin in the western sector, which is Ladakh. Geographically, we can divide this into the northern sector, with Daulat Beg Oldi, or DBO, and the Chipchap River. Then the middle sector around Galwan and Pangong, and finally, Demchok in the south.
What's fascinating here is the operational effect. Demchok was dangerously close to the newly built Chinese Aksai Chin Road.
Because of that proximity, the Chinese could easily branch off their main artery. Their heavy trucks could drive almost right up to the line of contact.
Meanwhile, communication on the Indian side relied on uncompleted roads. The road from Leh heading south toward Dungti was still under construction. If you wanted to move, you were walking on mule tracks.
Moving east, we reach the central sector, encompassing the borders of Uttarakhand and Himachal Pradesh. The topography here presents a very interesting historical contrast.
Yeah, because unlike the barren desolation of Aksai Chin, both sides of the border here had been well inhabited with a long history of mutually identified crossing points for traders and pilgrims.
It was a known entity, yes. But militarily, the infrastructure told the exact same story. At the start of operations, only mule tracks and footpaths existed. Forward roads were only undertaken after border troubles started. The geography was accessible to a trader, but impossible for an army.
Which brings us to the eastern sector, Nefa or Arunachal Pradesh. And within this, I want you to build a detailed mental map of the Khmer sector.
This mental map is crucial. The terrain here is structured around three prominent, massive ridgelines that act like giant descending steps from north to south.
Okay, picture three massive walls you have to climb over if you are marching north.
The highest, northernmost step is the Greater Himalayas Ridge, featuring the Bomla Pass. Below that, stepping down to the south, is the second massive wall, the Sela Massif.
And the Sela Pass sits at roughly 13,700 feet. That is a massive mountain structure.
And the third prominent step down is the Bomdila-Tamandala line.
So what were the actual roads like trying to cross these three steps to reach Tawang?
The surface communications were terrifying. They'd pushed a Class 9 road up to Durang. But after that, to reach Tawang by crossing the Sela Pass, the route degraded to a Class 5 road. And the records explicitly state this road to Tawang was constantly washed out by rains and landslides. All movement essentially had to be on foot.
And past Tawang, there were only mule tracks. But focus on the Namkachu River for a second, near the Sagal Ridge. The defensive line was anchored here. How did they move across this river?
The situation at the Namkachu is a tragic example of terrain paralyzing combat capability. The topographical reports mention the river had 7 bridges.
But the source has a striking detail here. Calling them bridges is an insult to engineering. They were actually just felled logs over an 11-kilometer stretch of a freezing, fast-flowing river.
Exactly. If you need to retreat, your only escape route is to balance walk across a wet log. The terrain completely dictated the flow of battle.
And we see that with the Babrang Chu River too, right?
Yes, the Babrangchu River Valley provided a natural infiltration route that allowed Chinese forces to simply bypass Tawang altogether. They used the terrain to walk right behind the Indian lines.
If we shift even further east to the absolute eastern extremity, we hit the Lohit sector. This place, with towns like Walong and Kibithu, is drained by major rivers, and passes are closed from November to May.
Walong sits in a bowl surrounded by hills, just 32 kilometers from the McMahon line. But the operational difficulties were staggering.
Staggering is right. The nearest Indian roadhead was 205 kilometers away at a town called Tezu.
205 kilometers. Ahead of Tezu, there were only foot tracks.
And the only means of crossing the fast-flowing Lohit River were 2 single 150-meter steel wire ropes.
You cannot sustain a modern military force at the end of a 205-kilometer foot track fed by wire ropes. Geography imposed severe sustenance limitations.
We've mapped the Earth, but in these mountains, the sky and the air are just as deadly as the terrain. Let's talk about the invisible enemies and allies, the climate and the air dimension.
Let's start with climate. High altitude, snow, sleet. The temperature plummeted below negative 50 degrees Celsius.
Negative 50. Metal becomes brittle. Skin gets frostbite in minutes.
The environment itself was an enemy, and fighting at that altitude mandates strict acclimatization. The Chinese utilized lower areas in the Tian Shan and Kunlun to acclimatize troops before operations. The extreme altitude took a massive toll on unacclimatized human life and vehicle engines alike on the Indian side because they were rushing troops straight up from the plains.
But here's where it gets really interesting. There is a fascinating geographical twist regarding air power. Everything about the plateau favored China, until you look at the sky.
What's fascinating here is the physics of high-altitude airfields. The Chinese had bombers at an airfield near Lhasa, but Lhasa is at a very high altitude. In thin air, jet engines generate less thrust and wings generate less lift. This severely restricted their aircraft payload capacity.
Conversely, Indian airfields, even forward ones like Leh, Chushul, or Walong's Otter Strip, or those deeper in Assam, were relatively lower. Because they were lower, they had denser air.
Right. Indian aircraft could fly with much higher payloads.
Hey!
Geography finally handed a structural advantage to the defense.
That is just incredible. Let's pull all these threads together to generate our final analytical matrix and the crucial takeaways for you to remember. Let's do a rapid-fire terrain comparison matrix.
Chinese strengths. Barren terrain allows sustained traffic, off-road movement, easy lateral connections. The high-altitude plateau offers staging areas.
Chinese weaknesses. High-altitude airfields severely limit air payload, and the need to cross the Sangpo River acts as a natural obstacle indicating major troop movements.
Indian strengths. Lower altitude airfields allow higher payloads. The mountains provide deep natural defensive lines.
Indian weaknesses. NS river valleys prevent lateral movement. Relentless monsoon rains cause landslides. Thick jungle hides enemy movement. Extreme gradients require monumental engineering efforts just to build a simple road.
So, if we extract the lessons, politically, militarily, and logistically, the framework is clear. Geography acted as a force multiplier for the side that understood it, and a force degrader for the side fighting against it.
Aksai Chin wasn't just a desolate rock, it was the geopolitical linchpin of military movement. To make sure you have this, here is a quick one-page revision sheet for maximum retention.
Important rivers. The Sangpo, or Brahmaputra, the natural obstacle. The Namkachu, remember the log bridges. And the Lohit, with the wire ropes.
Important passes, Karakoram, Lenakla, Bimla, and the Sela Massif.
And the key fact to remember, terrain plus infrastructure plus logistics equals combat capability.
So how will you view the world map differently now? Will you just see lines and borders, or will you see NS River valleys dictating lateral movement and barren plateaus offering strategic depth?
This raises an important question. In modern warfare, we talk about cyber and space. But the 1962 conflict proves that sometimes a frozen negative 50-degree mountain pass and a 205-kilometer mule track are the ultimate deciders of national destiny.
If geography is destiny, as we've seen in the Himalayas, how much of modern geopolitics is still being secretly directed by the sheer, unchangeable facts of the Earth's crust? where we can build a road and where we cannot, it's something to mull over. Until next time.